I'm Jerry Winslet along with Kenneth Ezel, and we'd like to welcome you to our monthly live show brought to you by HD Supply. What we're going to do today is we're going to talk about the top service items for gas. How we're going to do this is really we're going to kind of walk over. It really boils down to really one thing when it comes to gas. It comes down to no hot water. But before we begin, there's a couple things I need to talk about. There is a PDF download link at the bottom, right below the window there, what you're watching. You can go ahead and download what we're going to be covering today. You can just go ahead and follow along as we go along. Also, there's another link down there. We'll kind of talk about that towards the end of the show. But if you have any questions at all, go ahead and use the chat feature, which is on the right-hand side of your screen. Just go ahead and type that question in there, and we'll get to it as they come in. So how are we doing?
I'm doing fine, Jerry. How are you?
That was warm, though. Wearing that.
Yeah, it's pretty warm.
It got
a little muggy feeling.
All right, so let's go ahead and get started. We're talking about the top service items for gas water heaters, and we're going to talk about a couple different ones. We're talking about the mechanical style gas valve, and then the new electronic gas valve. But you know, when you're working on these things, and time is very important for these guys working on these water heaters. You know, we got to have the right tools to do the job, and we've got a few tools here we're going to talk about. The first here is the tool bag. This tool bag is a mobile shop tool bag. It's available at HD Supply. It really has everything that you're going to need to work on water heaters. Not only water heaters, but just general maintenance.
Yeah, just general maintenance. I used to do some apartment maintenance and stuff like that. And something like this is handy because you never know what you're walking in there to do.
Right.
Because usually you walk in, this is wrong. The next thing you know, you're re-weather stripping a door, fixing an outlet.
Yeah.
You never know. And so there's all types of different little handy tools in here that's easy to carry around that can help you out.
Yeah, so this is available on HD Supply. We've got, I think we've got the picture up now with the part number there. You can go ahead and take a look at that. Also, what we're going to use today, we're going to be talking about a couple of different meters, and I know we've got one set here. It's it's a tool kit, it's an electrical test kit. Let me go ahead and set that back over there. Again, this is available at HD Supply. This test kit comes with an outlet. You can test your outlet there, and you've got a non-contact voltage tester as well.
Yeah, if you're having problems with the receptacle, you know, you could plug this in and it tells you exactly what's wrong with it. Also, anytime you're doing any service to anything electric, I like to have a non-contact voltage finder.
Right.
That way, you know, I know it's off before I service it without having to use a meter. This is handy. It fits right in your pocket.
Right,
so.
and today we're going to be talking about the gas water heater, so we're really going to be talking about using this multimeter here. And it's able to test, you know, volts, but really it tests millivolts, and that's very important when we talk about gas water heaters.
Yeah, everything we're going to test on a gas water heater, you think gas water heater, what would I need an electric meter for? But gas water heaters do make electricity,
right.
And we're going to have to test it. And it's a very, very small amount of electricity. So it does need to check millivolts, and this multimeter right here from Klein tools actually, you know, serves the purpose of doing that. So.
Right, and again, this is available at HD Supply in a kit, and I think you can just get the multimeter by itself. So we got that out of the way. Let's talk about what we're going to talk about first is mechanical style gas valve. Mm-hmm. Now, you know, this is top service items, and I said before that, you know, you may get like pilot won't hold, pilot won't light, things like that, but it all boils down to one thing, and that's no hot water. I mean, because no one calls in saying, hey, my water heater's working great.
Yeah, they never call us and tell us how the large amounts of hot water that their water heater gives us. It's always the opposite. They usually have no hot water.
Yeah, they have no hot water, so it really boils down to this. And so you can go ahead and follow along with the PDF that's below the window there, and we're going to walk through these steps. And this is to troubleshoot no hot water, and it kind of covers everything that you know those top service calls would kind of encompass, all of it in the no hot water. So let's go ahead and get this base, and we'll get busy. So, you know, when we're talking about no hot water, and I'm a service guy coming out to an apartment or a home to do work on this, really, you know, the first thing I'm going to have to do is I'm going to have to verify that there's no hot water in the entire house, not just, you know, at one faucet. You may have hot water at one faucet, but not at another.
Yeah, the most common spot people are going to realize that they don't have hot water is in the shower.
Right.
And today, most of your shower controls today have built-in mixing valves, and they can fail. So when someone says they have no hot water, we usually like to have them check a couple different faucets, because you might not have hot water at your shower, you might have hot water at your faucets.
Right.
And if that's the case, it's not really a water heater issue, it's a plumbing issue. Right. So typically what I recommend is just going up to the water heater and just grabbing the relief valve, because it should be hot. Now, you want to be careful because that relief valve could be very hot.
Right.
You know, if the water temperature's turned up very high.
Yeah, so what we're going to do is we're going to go to the water heater and we're going to verify that there's no hot water in the entire building or entire household. That's very important. So we go ahead and do that. But if I'm a service guy going out to a job site and I do that, I've verified that there's no hot water, what's my first step?
Well, with the gas water heater, the first step you want to do is actually check to see if the pilot light is lit.
Okay.
On these water heaters, you know, this is just a base, so it's kind of easy to see everything, but this water heater is going to be installed in a drain pan, you know, sitting on the floor, most likely. So you're going to have to look in this little sight glass right here, the viewport, which means you're pretty much going to have to lay on the side of your head, right, to look into it and hope you can see in. And you have to look into the right spot, because the pilot flame's very, very small. It's a very small, very, very translucent or soft blue flame. And it can be hard to see, so you might even need to, you know, dim the room lights to see if you can see it. But we look inside up to the left through the viewport, and you should see the flame.
This one, it's up and to the left, is usually where these, so you'll look for your pilot. If you don't see a pilot, the first thing I'm going to do is I'm going to just relight the pilot. Now, I'm going to either light it or I'm not.
Yeah, it's either going to light or it's not, but just follow the lighting instructions on the water heater and try to relight it.
Okay, so we're going to light the water heater. We're going to follow lighting instructions on the water heater. We're going to try to light it. Let's say I go ahead and do that, and I'm holding down the pilot knob, and I'm clicking the igniter button, and I've got my knob set on pilot lighting, and I'm holding it down, clicking the igniter, and I've got spark, but I don't have a pilot light. Where am I going with that?
Well, if you have a spark, but you don't have, your pilot's not lighting, that means you're missing one of the three things you need for a flame.
Okay.
We have spark, which is our source of ignition. The other two things we need are fuel and air.
Okay.
When we're just talking about a pilot flame, it doesn't require a lot of air. So if you can breathe in the room, you have enough air for a pilot flame. Burner flame, when we get to that, is going to be a complete different story. So what we're going to be missing, since we have spark, we're sure we have air, would be gas.
Okay, so we're going to go down the gas road. We're going to make sure that there's no shut-off valves or anything impeding the gas getting to the water heater. One of the things that you had mentioned, we were talking about this before, is that this, you know, if it's in an apartment complex, this could be sitting vacant for a while, and you could actually get air in that gas line.
Yeah, if this is sitting in a vacant apartment, you know, the gas is probably going to be turned off to that unit for a while. So most gas regulators and meters are going to bleed down, which means you're going to have no telling how many feet of air in your gas line.
Okay.
And when we're trying to light the water heater, we're holding down the knob, which we're manually allowing gas to enter the valve. That gas has to go through a pilot tube and out of the pilot orifice to the pilot burner. Well, that hole in that orifice is smaller than the tip of a needle. I mean, it is absolutely tiny. And so if you have 30, 40 feet of air in your gas line, it may take 6, 7, even 8 lighting attempts to try to light this heater. Because it's not going to light until all the air's out.
Yeah, it's got to push all of that air out before it actually gets to the gas. All right, so if you're trying to light the pilot and you can't get the pilot to light, you're looking through the sight glass, you're holding down your pilot knob, you're clicking your igniter, and you do have a spark, because that's key too. If you don't have a spark, then you're not going to make flame anyway.
Correct.
So you've got a spark, but you're not getting a pilot light. You're going to take the gas road. You're going to go look down that gas road, make sure that you paid your bill, that you've got gas coming to it, and there's no air in the gas line.
Yeah, people turn shutoffs on gas lines off. And you never know, you could have multiple shutoffs, so you always want to check and make sure everything is turned on and that the gas company actually came out and turned it back on.
Yeah, that's very important. All right, so now let's say I went ahead and I'm holding my pilot knob down and I'm going to flip it around, and actually I do get a pilot light. I mean, it does light. but when I release the knob, it goes out. Which way am I going on that?
Well, if the pilot lights and you've held in the knob for the proper amount of time, because the thing is with these water heaters, you have to hold down the knob to allow the water heater to make the electricity it needs to hold everything down.
Right.
This water heater in particular uses a thermocouple. A thermocouple generates electricity by heat. It just converts the heat energy into electric energy, which holds down an electromagnet in the valve.
Okay.
So you have to hold down the knob and allow that process to happen. It could take up to 60 seconds. So if you've held in the knob for 60 seconds, you release it and it goes out, I'm really going to look for something electrical. I know it's not gas yet. I know it's not air or anything like that because it lights.
Right,
so all
right.
that's there. So it has to be something electrical, either with my thermocouple, the connection, the valve, something like that.
Yeah, so we're going to go down the electric road when we do get a pilot, because we made flame. I mean, so we had those three things. So it's got to be something electrical. We're not getting that signal back to our gas valve. Something's going on with that electrical signal.
Correct.
You know, what's the first thing I do if I do experience that? I mean, you know, where would I go with that?
Well, I like checking easy things first. So I'm going to check connections and things of that nature. Check and make sure my thermocouple's tight. It should just be finger tight, and that should be tight enough really for it to operate
Right.
and light. Really, it's supposed to be finger tight and a quarter turn just to snug it up. I'm going to check my connections here on the door switch. I'm going to check and make sure they're tight and not damaged or frayed or anything like that. And since I'm doing all this with my hands, and this is easy and fast, I might go ahead and press the button on the door switch to reset it if it tripped and see if it'll relight, see if anything changed.
Okay, so that's the door switch. That's actually our thermal cutoff on the water heater. And we're going to get to that particular device, safety device, in a moment, but that's a thermal cutoff. So our electricity coming from our thermocouple is actually going through that switch.
Correct. The electricity comes through the thermocouple, goes through these red wires through the pilot safety valve and the gas control valve, through the ECO, which is an energy cutoff. It trips if the water gets too hot and cuts everything off. But it has to make a loop. The power has to go around and go through all this stuff. And so if it's not going through something, it's not going to hold because the power's not going to go to where it needs to go. And it has to go through the switch. If the switch trips, it's not going to.
Okay, so let's assume that, you know, because most of the time it may not be that switch. So, I mean, let's assume that it's not the switch. Let's assume that the switch is closed, the contacts are closed. That switch has a set of contacts in it that when the combustion chamber gets too hot, those contacts open up and kill that circuit. It breaks the connection there, and so the pilot will just go out. It won't hold at all in that point. But yeah, let's assume that works, that this is good. And I'm still holding down my pilot, and when I release it, it just goes out.
Well, what I'm going to check next, and I'm going to check a couple different things, but now I'm to the point I've done everything that I can do easily. I'm going to need tools, and in this case, I'm going to need a multimeter.
All right.
You know, so I'm going to use this multimeter to check a couple of things. And the first thing I'm going to check is going to be one of the easier things because I can use my hands instead of finding a wrench or anything. I'm going to use the multimeter to actually check and see if my door switch is closed.
Okay, all right.
And I don't know if we can see this or not, but the multimeter has a continuity setting on it. And what continuity tells us is just that. We have a circuit. And so I'm going to turn my multimeter to the continuity setting and hold it to where you can see it. Okay. You see this icon right here. It looks kind of like a sound wave or a Wi-Fi symbol. Yeah. And can you hold that for me? What that tells me, if I have a closed circuit, it's going to beep. And so if I touch these leads together, you can hear the beep. And so what I do is turn my multimeter to that. I want to remove these two wires, right? Just remove them. I'm going to stick one lead to each terminal on the door switch, and if my meter beeps, you know, like this, then that means my door switch is closed and my door switch is good.
So we know it's closed, electricity can pass through that.
Correct, it's good, electricity can pass through it, that's not the problem.
All right, so once we verified that and we're still not getting a pilot to hold, what's our next step?
Our next step, what we're going to have to check with the meter is actually going to be the power output from our thermocouple.
Okay, so we're going to check to make sure that we're giving enough power to control this gas control valve.
Correct. We have to check and make sure we have enough power. Now, This is going to be a situation where you need a St. Patty's Day leprechaun, you know, to help you, because I'm really going to need 3 arms, because I'm going to have 2 arms or at least some alligator clips on my meter to check the thermocouple, but I'm also going to have to press this knob down and keep the knob pressed down the whole time.
Okay.
So if you're by yourself, it could be a little bit difficult. So if you have a little helper along the way, it's good. But I'm going to use my multimeter once again, and the thermocouple makes power, it makes millivolts.
Right.
So millivolts, I got to set it to the right range, because on this meter it's not auto ranging. I'll show you another meter later on that is.
So what kind of power are we talking about?
We're direct current. This makes DC voltage, but millivolts.
Okay.
And so what I have to do is actually set my meter to the proper thing. And so in this case, on this meter, I set it to voltage DC, which is right here.
Okay.
I hope you can see that. On a turn my dial, you see I have one scale, it's 200 M.
Okay.
So that means I could test anywhere from 0 to 200 millivolts.
All right.
A standard thermocouple, and this is important, makes 10 to 30 millivolts.
Right. Okay.
And I'll hold the meter, Jerry, if you want to show them.
So this is where you're going to have a couple hands. So what we're going to do is we're going to have to try to light the pilot. We are going to light the pilot. So you're going to have one person holding that knob down, other clicking, light the pilot, and then we're going to put one probe on the body of the thermocouple and the other on the head.
Yeah, and the important thing here is to make sure you keep this knob depressed, because if you don't, the pilot's going to go out and you're not going to get the millivolts.
Right.
And so what we're looking for, and this is very important too, is we have to have 10 to 30 millivolts. So anywhere from 10 upwards to 30 millivolts within 60 seconds. If we don't have the millivolts, then we know the thermocouple's bad.
Yeah, so we're looking for 10 to 30 millivolts. If you don't get that, then that's just an easy fix. We go ahead and just replace that thermocouple. We've got I guess you can bring up the slide there. There's the thermocouple right there. So you go ahead and you replace that. That's if you're not getting 10 to 30 millivolts.
Correct.
Now, what if you do get 10 to 30 millivolts?
Well, if I've gone through the troubleshooting so far, I know my door switch is good, I know my connections are tight, I've inspected them, I know my pilot lights, I know my thermocouple is good. About the only thing left is going to be something with this control valve.
Right.
It's odd that they would fail, but it's not impossible. So if everything checks out, it just means there's something has failed inside here. Either the pilot safety valve has failed, which is an electromagnet, or the ECO is tripped, which is an energy cutoff that trips if the water gets too hot.
And they have to replace it if that happens.
Yeah, the valve's non-serviceable, so at that point you'd have to replace the valve. So if everything else checks okay, the only thing left would be this.
Okay, so we would go ahead and replace that. We got a slide there for that gas control, but that doesn't happen very often at all. So what you would be doing is you're going to test for that 10 to 30 millivolts on that thermocouple. If it doesn't have 10 to 30 millivolts, go ahead and replace the thermocouple. If you do get 10 to 30 millivolts and everything else checks out, you've checked out the door switch, you've checked all your connections, then the only likely thing it would be your gas valve.
Correct.
All right, so that's if the door switch right here did not trip. I mean, we press the button, we check continuity, it has continuity, electricity can pass through it. But let's say we get to the water heater, we press this button, and it did trip. Now that's a different story.
Correct, and the whole purpose of the door switch is to trip. It's a safety feature. It pretty much is there to prevent the water heater from making unsafe levels of carbon monoxide.
Yeah, because it's a thermal switch, and it's funny because, you know, this is the hottest part of the water heater.
Correct.
And you're putting a thermal switch there. That's kind of
correct. We put a switch that activates if it gets too hot, and you would think, well, that's crazy.
Yeah.
But we know that the combustion chamber is going to get hot. We heat water. That's the whole purpose. But it should be a certain temperature as long as we're moving air. If air's coming in through the flame arrestor and the filters of the water heaters, the combustion chamber should be a certain temperature. And if it gets hotter, that means our air movement has stopped. So typically, if the switch is tripping, it generally means we have a dirty filter or an air issue.
Okay, so all of the combustion air is coming through this flame arrestor right here.
Correct.
So yeah, and we've got a wraparound filter on the water heaters, so we'll need to clean that filter. That could be the case, or the actual flame arrestor is dirty, and that's something you'll have to clean as well. You're going to use a long handle, soft bristle brush. You're going to clean the filter that's around the water heater, but then clean that flame arrestor. And you're going to go ahead and clean it off, pull it out, use a vacuum cleaner and vacuum off the lint or debris. And you keep repeating that process until the brush is clean, until you're not getting any more out of there.
Until the brush is clean. And a lot of times these water heaters are going to be installed in utility closets, or you know, where the washer and dryer is. And
Right.
dryers put out lint, and the filters will eventually get dirty. Or if it's in a louvered closet with an air handler, that
Exactly.
closet sucks in a lot of air. This water heater does. The louvers could get blocked over time. So just one of those maintenance things. Make sure all those are clean and usually good to go.
Now, another thing too that we can talk about is, I mean, maybe they have cleaned the flame arrestor. Maybe they've been doing that, and that's not the issue. And we're just not moving the right amount of air out of the water heater, and the flue just kind of gets stagnant and basically can stop at some point. We're not getting it out of the building. We're going to talk about that test to make sure the water heater is working properly, venting properly, when we get done with electric, because it's basically the same test for both water heaters.
Yeah, it's going to be the same test for any standard atmospheric vent water heater. That relies on natural draft to get rid of the flue product. So I know we're going to show that here later on when we go to the other heater.
Yeah, we're going to go ahead and do that. So that's the mechanical version of the standard atmospheric gas water heater. They're still out there. You're going to see them. So just get familiar with it. And if you can do those tests, you're going to be able to work on pretty much any of the most common calls that you get with these water heaters, because it all boils really down to, you know, I didn't have any hot water, and that's why I'm calling you.
Correct.
So go ahead and take this PDF, keep it with you, put it in your truck, use it, and like I said, you know, it kind of walks you through exactly what we just talked about. All right, the next thing we're going to talk about is the electronic version. Now, before we're going to go over to a water heater. We have one installed over here in Studio B. We're going to walk over there in just a moment. Well, I want to go over some of the parts that are different from the mechanical style. You know, it's still a standard atmospheric water heater. We don't plug the water heater in, and it basically works the same way. It's just some of the parts are different. Let's talk about it. The first thing is that the gas valve looks a lot different.
The gas valve does look a lot different. This gas valve is an electronic gas valve. It doesn't plug in the wall, but it does look a lot different. And a couple of the features you'll notice, the mechanical valve has two knobs. Has a pilot control knob on the top and a temperature knob right on the front of it. All that has been really combined into one knob on this.
Okay.
So this is not only your pilot knob, it's also your temperature knob. The spark igniter is also built into the valve. You can see it right there. I can't see it, but it's
got
built
a spark
in.
igniter, and you've got a status light on there.
Yeah, you do have a status light. That's the big difference with this water heater. There are some things that could go wrong with it, and if it does, it actually gives you an error code and tells you, you know, what to do to it. So that's good. But since we do have a status light, since we do, you know, give error codes, a couple other things have changed.
Okay.
And one of the big things that has changed is our power source.
Right.
On a mechanical valve equipped heater, it takes a standard thermocouple. Remember, we're talking 10 to 30 millivolts. This heater uses a Thermopile, which makes a lot more power.
Right, yeah. It's a Thermopile. It's basically what a Thermopile is just a pile of thermocouples. It's about 20 thermocouples, all encompassed in one piece of metal here. So it's got to heat up, and we're generating upwards of 350 millivolts all the way up to, I mean, we've seen in new water heaters up to 900 millivolts.
Yeah, you can generate a lot more power with this. So the thing is, I mean, it pretty much works the same. It converts heat energy into electric energy. You can see the Thermopile there. The flame burns onto it just like it would a thermocouple. It all really works the same. And other than some of that, everything else is pretty much the same. We're using the same flame arrestor.
Burner, door switch.
Door switch, door assembly. Of course, a thermocouple screws into the bottom of a mechanical valve, which means to loosen it, test it, you have to have a wrench or some pliers to loosen it, which you have your kit, so you usually have some stuff with you. But this one's actually easier. It just plugs in.
Yeah, and another thing too, I mean, we said this is electronic. I mean, it's a digital valve as opposed to the mechanical style. We're sensing temperature different in this one as well.
Correct. The old mechanical valve just uses a copper probe that goes into sits in the water of the tank. You have to rely on expansion and contraction of metal to sense the water temperature, but it works good. We've been using it for a long time, the whole industry. This one actually uses a thermistor.
Okay.
A thermistor is just far more accurate. It gives you better temperature control. It's tighter tolerances.
Okay.
And so that's good.
Yeah. So you've got this right here is your dry well thermistor. There's a thermistor inside here. So this sticks directly into the water. And like we said, you know, this gas valve will give you diagnostic codes. I mean, it will tell you if there's something wrong with it. The thing is, we don't plug it in. So the one thing you have to have in order to have a code is a pilot light. And if it's out, we don't get any code.
Yeah, if the pilot goes out, we do not have a code. Everything this heater does for power, it generates it on its own by heating the Thermopile and that power getting back to the control valve. And so the pilot goes out, you don't have any power, you don't have any code.
Right, yeah, you're only going to be really concerned with, there's a couple of different codes that you would probably be concerned with. First is zero or no code. That means that the water heater's off. You'll have a 1 flash, which would be a normal operation, 1 flash every 3 seconds. You might experience from time to time a 2 flash. You know, a 2 flash is actually telling us that the Thermopile is getting weak. And you might experience that from time to time. But what we're going to be concerned with today is this. The only way you have any of these codes is if you have a pilot light, besides a 0. We're going to be concerned with 0 because, you know, we're talking about no hot water on this one as well. So, I mean, the customer's going to call in and they're going to say, I have no hot water. And I'm going to verify it like I did with the mechanical. I'm going to go to the water heater and I'll put my hand, make sure that there's no hot water. And then what am I going to do?
Next thing I'm going to light the pilot, follow the lighting instructions, see if I can get a status light.
Yeah, because you won't have a status light. So we're going to go ahead and relight that pilot, just like we did with the mechanical style. You're either going to light it or you're not going to light it. If I'm holding the knob down, I'm clicking this button, and this takes a little bit longer to light than the standard mechanical gas valve. So when I'm holding the pilot knob down and I'm clicking that button, you know, when you light this pilot, first, let me talk about this. When you light the pilot, I'm not going to have to stand on my head to look through here to make sure it's lit. I just can wait for that status light, right? Yeah,
lighting this heater, it's a little bit different. We don't have to hang upside down like a bat and try to look into the window. We can just look for the status light. Now, it may come to a point to where you eventually need to look in the window. If you keep, after multiple retries of trying to light it, you never get a status light. But, I mean, for the most part, just makes it easier. Hold in the knob, click the button, keep doing it till the light starts flashing.
And it's going to take about 90 seconds for this to work, correct?
Correct, because a Thermopile, like you said, is a pile of thermocouples. It takes longer to convert that heat energy, and we need more power, so it takes a little bit longer for us to get the amount of electricity we need. So typically on a Thermopile heater, we're going to look for 90 seconds, or try it for 90 seconds to see if it lights.
Yeah, and it's the same thing. I mean, if it doesn't light after 90 seconds, you're going to look through the sight glass, or a couple times. You're going to try it a couple times. You're going to look through the sight glass. If you don't see a pilot when you're holding down the knob and you're clicking the igniter, you have a spark, but you don't have a pilot, then we're going to go down the gas road again.
Correct.
Same thing. We're going to check for shutoff valves. We're going to talk about air in the gas line, things that are stopping the gas coming to the water heater. And really, after you do that, you know, you check the gas, but if you do get a pilot, we're just going to flip down to, if I do get a pilot and I'll release the knob and I'm never getting a status light, that's a little different. Then I'm going to go down the electric road, but that's a little different on this water heater.
Yeah, testing on this one's going to be a little bit different because you don't have a thermocouple, and so we're going to have to test it a little bit different.
Yeah, and what we're going to do right now, we're going to go over to the water heater. We're going to talk about testing this water heater, and then we'll end it with a test that you can test on both water heaters. So
correct.
Come with us. All right. All right, so, you know, we've already talked about the gas. You know, we're trying to light it for 90 seconds. We're looking through our sight glasses. We'll have to take this door off. We're looking through there. We're holding down our pilot knob, and we're clicking our igniter, and we're looking through the sight glass, but we never see a pilot we never get one, you know, we're going to go down that gas road.
Correct.
Yeah.
We're going to check to make sure that the gas is turned on, and we're going to remember if the apartment or wherever the water heater is has been vacant for a while, that we're going to have to do multiple lighting attempts. That pilot orifice, I cannot repeat it enough, it is little. And so it may take multiple attempts of trying to light this for 90 seconds at a time to get it to light.
Yeah, so just take the gas road. Now, but if I'm holding this down and I'm looking through here and I do get a pilot, and I have a pilot, but I never get a status code, now that's when we're going to go down the electric road, and that's a little bit different on this one.
Correct. I'm going to check some easy things first, kind of like we did on the other. The first thing I'm probably going to check is my connections here. I'm going to check and make sure on this door switch to make sure they are connected properly. As you can see, it's just 2 red wires that go to it. Let me kind of move this out of the way some. Another thing I want to do is just go ahead and just reset the switch like we talked about earlier. Use my finger, press the button, might hear a click. If I do go through the lighting process, you will get a light then, and it should be good to go.
But let's say this isn't tripped. Let's go down that road first. So we don't have a tripped door switch, and we verified it because we're going to use this. This is another meter actually that's available at HD Supply. It's actually got a clamp-on amp meter on there, doesn't it?
Yeah, this one has a clamp-on amp meter, which is great if you're working on an electric water heater. Clamp around, see if it's working or not.
Yeah, I think we've got a shot of one that you can look at there. All right. So our door switch didn't trip.
Yeah, door switch didn't
trip, and now we're still trying to light it. We're looking through there. We lit the pilot, but we're still not getting a status light, and we verified that the door switch is not tripped.
Yeah, once we verify the door switch is not tripped with our meter on the continuity setting, I'm actually going to check the millivolt output of my Thermopile.
All right.
Now the way, I like this a little bit easier in a Thermocouple because like I said, Thermocouples you got to be kind of careful with them.
Yeah, you're going to have, and plus you got to have 3 hands.
Yeah, you have to have 3 hands. You're going to have some pliers or a wrench or something to loosen it up and make sure when you tighten it back up that you don't over tighten it. But with the heaters with the Thermopile, if I can get a shot, and I'll try to get my hands out of the way, the Thermopile, you don't even have to unplug it. All I have to do, there's a little barn door on the back side of it with a tab. I just pry open the tab and I can hold it up and I can actually get to my connectors.
Okay.
That's the connectors that my voltage is going through. And what I can do is just peel that up, use my leads, and check to see my millivolt output of my Thermopile.
Okay.
Testing it's similar to a Thermocouple in a couple ways. I mean, I have to have a multimeter one, but all I do is peel that up, stick my leads to touch each of the wire connectors, as shown. Let me move my hands down where you can kind of see. It just has to touch the metal of each connectors. And then once again, I light the pilot, so we turn the knob to pilot, press it in, start clicking the igniter. Once the pilot lit, I'm going to give it 90 seconds to warm up.
Yeah, because you're looking for 350 millivolts when we're talking about, that's your magic number, 350 millivolts and up. And it won't just say 350 millivolts when it lights. I mean, it's going to warm up, and as it warms up, we're going to generate more electricity.
Correct. The warmer it gets, the more electricity we generate, and it may take a while. That's why we have to give on this unit 90 seconds.
Yeah, and you can put those, you can probably push those in to the point where you can leave them. I mean, at one point you can.
Yeah, if you push them in there the right way, you can kind of let go and they'll stay there.
And then you can go ahead and use both hands to light the water heater. But all you got to do is light it, look through there, click that igniter, just enough to light it, and then go ahead and check that. Now you're looking for 350 millivolts. If you don't get 350 millivolts and all of your connections are good, I mean, you've done everything right, it's got to be the Thermopile.
Yeah, it's going to have to be the Thermopile on this unit, so we'd want to go ahead and replace the Thermopile.
Yeah, and you want to make sure you wait at least 90 seconds before you do that.
Correct, and it takes time. Definitely it does take time to generate that much electricity on this unit, so give it the 90 seconds. If it doesn't generate it, 350, at least 350 within 90 seconds, replace the Thermopile.
Yeah, I think we've got a shot of the Thermopile up that they can put up there now. That's the Thermopile.
And it's going to be the whole assembly on this water heater. So it's going to be your Thermopile, the pilot tube, pilot burner, and all that.
Right. So go ahead and replace the Thermopile if you're not getting 350 millivolts. What I do is I just wait until it stops, the voltage stops climbing, and then if it doesn't hit 350, then you know. But let's go ahead and say that it did hit 350, and it's way up there. You know, you're getting up in the 500, 600 millivolts. Then again, it's the same thing as the mechanical style. If all my connections are good, I'm looking at one thing, right?
Correct. If my connections on my door switch are tight, they're not corroded or anything going on with that. My Thermopile connection's tight to the heater and the wires aren't damaged or frayed. You know, a cat hasn't been chewing on them or anything, or a dog.
A cat or dog, yeah.
So if my door switch is closed, I do have power and my connections are good, it's going to be something with the gas valve if I never get a status light.
Man, we've got a shot there of a gas valve there. Yeah, so it would be the gas valve. You go ahead and replace the gas valve in that case. Doesn't happen very common, but that's the only thing it could be at that point.
Correct.
Is the gas valve. So you've checked everything. So there's two roads that you're going to go down when it comes to these gas water heaters. You're going to go down the gas road, or you're going to go down the electrical road. And electrical meaning the signal coming back to the gas valve is really what we're looking for. And it really comes down to if you can light the pilot or not, really.
Correct.
So if you can't light the pilot and you've been trying, you go take that gas road. If you can, you take the electric road. And just follow the steps that are in here. Now that being said, the last thing we want to talk about is if the door switch does trip on both water heaters. If the door switch trips and we've ruled out, cleaning the flame arrestor, we've already done that, and we've determined that we're just not moving enough air. What do we need to do?
It could be that we're not moving enough air. And as Jerry said, we've cleaned both screens. This heater, you have the screen on the outside, you have the flame arrestor on the inside. Clean them both, make sure they're clean. The next thing we really need to do is a draft test.
Right.
To see if the water heater is moving the proper amount of air, and just to make sure that the room the water heater's in, or the way it's installed, has enough air for it to move.
Right. So let's talk about a draft test now.
All right, well, let's
we're going
stand
to go
up.
ahead and stand up. It's important that you do this. This is going to tell us that the water heater's working properly and drafting properly. That means we're getting that combustion product up and out of the structure of the building.
Correct, and it's also going to tell us that our installation is working properly because you have to have air.
Right.
The way any gas water heater like this heats is it moves air, it heats it, the hot air naturally rises, the cold air naturally falls, and it starts draft. And so if everything's clean, it's tripped and door switch, we must do a draft test to see if all this process is happening correctly.
Okay, let's walk through the steps of doing one.
Well, there's a couple of pre-steps you need to do. When doing a draft test, really what you have to do is you have to turn on everything that may normally be on.
Okay, that requires air, right?
That requires air, removes air from the facility or from the home it's installed in. And that's going to be your bathroom vent fans, the range hood over your oven.
Dryer,
that removes air. If you have a gas furnace, or there's a couple other little things. Anything that removes air from inside and puts exhaust outside.
Okay, so we're gonna turn on all the gas, or turn on the appliances that use air.
Yep. Make sure all windows are closed that are normally closed. Make sure all doors are closed that are normally closed. And then the heater has to be lit and the burner has to fire.
Okay.
So we have to light the burner to make sure that, all this is happening, right? And so we're going to light the burner. Then we have to get a smoke device. And up here at the top of the heater, we have the draft hood or draft diverter.
Okay.
And what this does is helps bring in air to make sure in some cases that we don't overdraft.
Okay.
And so it just breaks the vacuum a little bit. And you see around it, if you can get a shot of it, you have openings all the way around it. And so to pass a draft test, that means that we got to get a smoke device, whether it's a little thing you light firecrackers with, or you wouldn't want to use a cigarette, but if you smoke, I guess you can use a cigarette or a vapor box.
Or you can just light a piece of paper on
a piece
fire,
of
blow
newspaper.
it out, and then put it up there.
Yeah, just be careful. I know some places have sprinkler systems in it. You don't want anything to get out of hand.
A punk usually works the best. That's what you light firecrackers with.
Correct. So,
I think that's what we're using in the PDF there.
Yeah, in the PDF. And so what we do is put the smoke device right here near the draft hood, and it should pull in the smoke. If it doesn't pull the smoke inside and up through the venting, you have a problem.
Okay.
If it blows the smoke away, you have a dangerous issue where the exhaust is actually coming back into the into the home, right?
It's basically using this, this vent as a straw, pulling air from the outside in, right?
Correct. You have something in the place that's using more air than this water heater can move, and so it's going to use it as a straw to provide whatever that appliance is for air.
Okay.
Which means the place just doesn't breathe well enough or good enough.
And what would cause, now, I mean, I'm talking about, you know, the door switch did trip. If we're not moving the combustion product out, it's going to superheat down there, right?
It's going to superheat because as the hot air rises, it pulls in cool room air behind it. And it keeps the combustion chamber pretty constant temperature. But if you stop moving air, that means cool air is no longer coming in. The air inside the chamber is going to get super hot. And once it gets too hot, that switch is going to open, kill my electrical signal, and shut everything off.
So my solution would be get more air to the heater, correct?
Get more air, and anytime these water heaters are installed, it tells you in the manual the air requirements for it. But as I said earlier, sometimes it's simple. If someone has lived inside a apartment or wherever for a while, the water heaters are usually installed in utility rooms or small closets with air handlers. It might have a louver door. The door may just be blocked up. The filters may just be blocked up. So clean, make sure everything's clean, because if it worked in the past and now it's not working and it's tripping the switch, it's just dirty.
Or, you know,
it's
in a tight space, and people like to put stuff in those spaces, and they just pack that place with coats and stuff that's going to take up room, and that's going to take up your air as well.
Yeah, I mean, anywhere people can stuff stuff, they're going to stuff it in there. You know, it seems also like people put their most prized possessions near an appliance they know is eventually going to leak. It's not a very good idea, but make sure it's installed properly in a drain pan. But yeah, I mean, anytime you put something in the closet with this water heater, you're removing air that it needs for combustion.
Right. All right, so what we need to do is go ahead and keep those PDFs. Download them, keep them with you, print them out, take them with you on the job site, use them if you're working on any one of these, either one of these appliances. You know, they're going to help you in the field. Also, you know, if you have any questions about anything that you've covered here today, you can email us at university@hotwater.com. Also, I mean, if you have any questions now, you can go ahead and type them in. We'll be more than happy to talk to you about it. Let's go back over to the desk there. Grab my stuff. All right. So, like I said, you know, if you have any questions about anything we've covered, email us at university@hotwater.com.